Tech Talks Education. Let us continue with the chemical bonding, and we look at our next type of bonding, that is the metallic bonding. Metallic bond. So, as the name says, metallic, it means that a metallic bond forms between atoms of a metal only. It doesn't form between atoms of metals. It is between atoms of a particular metal. If the metal is sodium, then it should be formed between atoms of sodium. If the metal is magnesium, then it should be the magnesium atoms that should bond together to form what we call a metallic bond between them. So let us see how it is formed. It is formed as a result of the complete loss of electrons from the outermost shells of a metal atom. So the electrons in the outermost shell of a metal atom gets lost completely. And where do these electrons go to? They remain within the metal. That means they remain moving around in between the empty spaces between the atoms in that metal. That's what we call the metal lattice. So they are formed as a result of the complete loss of electrons from the outermost shells of metal atoms, of atoms of a metal, since we deal with one metal, of atoms of a metal. And where do these electrons go? Into the metal lattice. That means the electrons do not just escape and go outside or get lost completely. They remain within the metal lattice, within that metal, but they are not attached to any particular atom this time. So what happens next is that the metal atoms therefore becomes positively charged. So when these metal atoms lose electrons, they become positively charged, with the number of positive charges depending on the number of electrons lost from the outermost shells of those atoms of the metal. So next is that since the electrons which are lost and are within the metal lattice are negatively charged, and then the metal atoms are now positively charged, they are developed attractive forces. So we say attractive forces, that's the electrostatic forces of attraction, develops between the negative electrons and the positively charged metal atoms. So in this case, those electrons within the metal lattice are negatively charged and the metal atoms are now positively charged. So next is that the metal atoms, in an attempt to move closer to the electrons, they touch one another and get bonded. So the positive metal atoms therefore draw closer towards the negative electrons in the metal lattice and gets bonded to one another to form what we call the metallic bond, and that's what we call the metallic bond. So the process is very simple. Metallic bonds are formed between atoms of a metal, not between atoms of metals, but between atoms of a metal. And then we say that what happened is that within a metal or within a metal lattice, the atoms of the metal lose all the electrons in the in their outermost shells, and in the process they become positively charged. Those electrons remains moving freely, or what we call free moving electrons. We find them in the metal lattice. So the atoms of the metal becomes positively charged, and those atoms, because of being positively charged, they tend to draw closer to the electrons which are negatively charged, and they are within the metal lattice. So as they draw closer to one another, towards those electrons in the process, they tend to narrow the distance between them, and eventually gets what? Bonded. And when they get bonded, they form what we call metallic bonds. That's why metals normally are solids at room temperature, because the atoms are densely packed because of the metallic type of bonding. So that's how a metallic bond is formed in this case. So let us look at the characteristics of metallic, characteristics of the metal formed as a result of metallic type of bonding. So let us look at the characteristics or the properties of metals. One, they are usually solids at room temperature. This is because of the metallic bond between the atoms, which makes them to be densely packed. So they are solids at room temperature. Two, they are insoluble. Metals cannot dissolve in water. If it can in any way interact with water, it simply reacts with the water to form, say, different products. But metals cannot dissolve in water. Not only that, they have high melting and boiling points. Metals have high melting and boiling points. Then you must know that this characteristic here is similar to the characteristics of the ionic compounds. The difference here is that metals are insoluble in water, but the ionic compounds are soluble in water. That's how you can distinguish between metals and then the ionic compounds. That ionic compounds and metals, yes, they are solids at room temperature, they have high melting and boiling points. Only that with solubility, metals are insoluble in water, and then the ionic compounds are soluble in water. Another thing is that they have high densities. The particles are densely packed, and for that reason they are dense, they are hard, they have high densities. Apart from mercury, which is a liquid metal at room temperature, but usually metals are solids at room temperature and they have high densities. Next, they conduct electricity in both the solid and molten states. Metals conduct electricity in the solid state and also in the molten state. But you cannot get an aqueous solution of a metal because metals cannot dissolve in water. So, ionic compounds, we know that they are electrolytes. Electrolytes are compounds, not elements like metals. So, in this case, metals are not electrolytes. In this case, metals are elements. They are not compounds. And they conduct electricity in the solid state very well. They even conduct electricity in the molten state. A molten metal, when heated to the melting point that it melts, then the melt conducts electricity. Even the solid metal conducts electricity. So, these are the characteristics or the properties of metals. They are solids at room temperature. They are insoluble in water. They have high melting and boiling points, and they have high densities. As well, they conduct electricity in both the solid state and the molten state. Unlike the ionic compounds that cannot conduct electricity in the solid state. But do not refer to metals as being electrolytes, because electrolytes are compounds. So the ionic compounds are electrolytes because for them they conduct electricity in the molten state and in the aqueous state. So metals conduct electricity even in the solid state, but they are not referred to as being electrolytes. They are just conductors of electricity, not electrolytes. So that is that with the properties of metals. Tep Talks Education. Thank you for watching.